This portion of the virtual field trip deals with Galveston Bay and the jetties located on the east end of Galveston Island. But first, let's go back a few thousand years and look at the origin and evolution of Galveston Bay. The last glacial episode extended from 75,000 to approximately 11,000 years ago, and during the last glacial maximum, at about 18,000 years ago, sea level was nearly 100 meters or 330 feet lower than it is today. And during the last glacial maximum, the shoreline extended out to the present-day continental shelf, such that what is today flooded was back then exposed subaerially. As a result, rivers flowed across the exposed continental shelf while carving incised valleys and depositing sediment far offshore of the modern coastline. So here's a map or an illustration showing the Texas Gulf Coast from 80,000 to about 22,000 years ago. And notice that back then, the coastline was 50 miles further south near the shelf edge, approximately along what's labeled as the 100-meter contour. Now the San Jacinto, the Trinity, and the Brazos, and also the Colorado rivers flowed across the exposed shelf, and these flowing rivers eroded the shelf sediments, carving incised valleys indicated by the black, in addition to depositing deltaic sands and silts and clays over the shelf muds. Now when the Ice Age ended, beginning about 17,000 years ago, sea level began to rise and the ancient coastline began migrating northward or landward across the shelf. The previously deposited deltaic sediment was picked up by the rising water and transported landward along with the shifting coast, such that much of this transported sediment would eventually form the modern coastal features like beaches and barrier islands that we find along our present coastline. So let's briefly look at the Holocene evolution of Galveston Bay. Now notice that since the last glacial maximum 18,000 years ago, as the Ice Age ended and glacial meltwaters returned to the oceans, sea level gradually rose over the next few thousand years. Now prior to 9,600 years ago, the area of what was to become Galveston Bay was essentially dry land. And we see in this figure to the left the outline of the modern Galveston Bay. Now back then, the ancient San Jacinto and Trinity rivers flowed through this region, depositing fluvial or stream sediments within the valley. As sea level continued to rise, the approaching coastline transformed part of the valley into a swampland as part of the evolving deltaic complex. Sea level has risen considerably, but still not anywhere near its present level. Now sea level continued to rise, and by 7,700 years before present, the deltaic facies shifted further up the valley due to the encroachment of bay waters further to the south. Sea level briefly fell around 7,700 years before present, and sediment brought in by the encroaching Gulf of Mexico accumulated in the southern portion of the bay, and created an extensive shallow water environment, essentially a tidal flat, where the exposed sediment was reworked by waves and currents. Now, sea level reached its present level about 6,000 years ago, and at that point completely flooding the ancient river valleys to eventually form what we know today as Galveston Bay. Now, the barrier islands along the present coastline began to form approximately 5,000 years ago once sea level approached its modern height. Now, in terms of construction of the Galveston Barrier Island, the majority of barrier islands along the upper Texas coast formed after 5,000 years before present, when the rate of sea level rise decreased from about 2 millimeters per year down to only 0.6 millimeters per year. Galveston formed as an accretionary barrier island in that it grew gulfward with the addition of sediment supplied by wave action and longshore currents. So here in this upper figure we have the original erosional surface upon which Galveston Island was constructed. And by 3,500 years ago, we had the shore face extending along what's shown as this particular contour. But then, over time, with the addition of sand, the shore face grew steadily gulfward. Here's the shore face 2,000 years ago, 1,200 years ago, 800 years ago, and then over towards the far left, this constitutes the modern shore face of Galveston Island today. Now, Galveston is considered a regressive barrier island in that sedimentary facies reflect progressively shallower water deposits from the base to the top. We see in this lower figure, for example, that the deepest water sediments, the offshore sediments, form a layer at the very bottom, but then as we go up this sequence, the deposits become progressively shallower water deposits, ranging from offshore to lower shore face to upper shore face, and then finally to the beach deposits, which form the very uppermost layer of Galveston Island. Now, these growth of barriers all along the Texas Gulf Coast eventually stopped as sand supply gradually diminished, such that the barrier islands are now eroding due to several factors. One, sea level is currently rising again as a result of global warming at a rate of about 2 millimeters per year. There's also been an increase in tropical storm activity. The sand supply to the upper Texas coast is minimal, and sand that is removed and transported westward by longshore currents is no longer being adequately replenished. In addition, we had the construction of artificial barriers such as jetties, groins, seawalls, and so on. Now, the entrance to Galveston Bay is essentially a tidal created by tidal currents that breach barrier islands. And this photograph is an example of a smaller tidal inlet for comparison with the entrance to Galveston Bay. And notice that during rising tide, water flows into the bay and deposits a flood tidal delta landward of the inlet. But then, when tides fall, bay waters flow back out into the Gulf, depositing a ebb tidal delta on the seaward side. And so too here in this photograph, or this sketch rather, this is Galveston Island here. This is the east end of Galveston Island. This is the Bolivar Peninsula up here, and this is the entrance to Galveston Bay. And within this entrance, waters entering the bay deposit the flood tidal delta, whereas waters that exit the bay carry sediments gulfward along with it. Now, in order to understand sedimentation in and around Galveston, we must also consider wave refraction and longshore currents. Now, as waves approach the beach, the rows of waves bend in a direction more parallel to the shore in what's referred to as wave refraction. The end nearest the shore encounters shallow seafloor first, thus slowing down, while the end further from shore is moving faster and eventually catches up to the near shore end, causing the waves to bend to near parallel alignment with the coastal area. Even so, waves approach the shore at a slight angle, such that when waves wash up and back on the beach, this causes the grains to move down beach in a zigzag pattern known as beach drift. In addition, longshore currents are also created offshore that parallel the coast, and these longshore currents transport sediment in the same direction offshore as the beach drift is occurring onshore, so that the net result is that there is a net transport of sediment both on the beach and offshore in a down beach direction. So let's look at Galveston's wave and current patterns. Waves approaching the coast at a slight angle in what's known as wave refraction generate longshore currents that flow offshore and parallel to the coast in a general east-west direction. Now, the sediment transported by tides, beach drift, and longshore currents ultimately accumulate at entrances to harbors. Harbors must be periodically dredged in order to maintain enough depth to accommodate large ships, and this dredging can be very expensive. Jetties are therefore structures that are constructed at entrances to harbors to help keep sediment from accumulated within the harbor. And notice that these jetties are always constructed in pairs. Jetties also act as breakwaters that permit safer navigation. Now let's consider the east end of Galveston Island at the entrance to Galveston Bay, and the red star indicates our location at the eastern end of the seawall. Now note the pair of jetties at the entrance to Galveston Bay, and also note the large ships that are entering and leaving the harbor between the jetties. Now the question becomes, how do these jetties affect the sediment transport along the coast? Let's go back to our illustration of Galveston wave and current patterns and note the longshore currents that are moving towards the west. Now the jetties in this figure are represented by the two red lines at the entrance to the Galveston Bay, and note that the jetties interrupt the longshore currents, causing sedimentation. What's more, sediment buildup behind the south jetty in the area known as Apfel Park has occurred to such an extent such that some of the sediment actually spills out into the adjacent harbor. What's more, currents also reverse direction at times and flow eastward, piling up more sediments against the south jetty. So when we look at Apfel Park, we see that enormous volumes of sediment are accumulating behind the south jetty. And note also the spillover of sediment into the adjacent harbor. Now the jetty along the beach is mostly buried beneath sand but reappears within the Gulf. And as a result, Apfel Park is one of the few constructional beaches on Galveston, in that the beach here grows at a rate of several feet per year as a result of the continued accumulation of sediment behind the South Jetty. Now, in this figure that we looked at before, note the deflection of the longshore currents, the white arrows, against the back of both the North Jetty and also behind the South Jetty. Now, Big Reef, adjacent to Appville Park, is the site of the sediment spillover. And what's more, we see significant sediment accumulation occurring behind not only the North Jetty, but also the South Jetty. Also note the sediment within the bay. Now, assuming that the sediment transport by way of longshore currents is mainly from east to west, or in this figure from top to bottom, what are the beaches further west receiving much sand? In other words, what is happening to the sand-starved beaches located further west? Now, jetties serve to trap and accumulate sediment such that beaches both further east and west are sand-starved, in that not enough sand is reaching these beaches to replace the sediment that is lost due to erosion. Now, the figure to the right shows the net addition or removal of sand on beaches in feet per year, where positive values indicate that the beach is growing, whereas negative values indicate that the beach is eroding. And notice that the only positive values in this figure occur around the jetties, in which case this tells us that the beaches are growing in these locations at a rate of anywhere from 8 to 12 feet per year. But as we move further away from the jetties, in both the eastward direction and also towards the west, we see that those values are mainly negative, indicate that the beaches, both east of the jetties and west of the jetties, are undergoing net erosion. In other words, these beaches are sand-starved because of the pileup of all the sediment around the jetties that would otherwise be transported further towards the west by longshore currents. And as a result, these beaches further east and west are sand-starved, in that not enough sand is reaching these beaches to replace the sediment lost due to erosion. What's more, there are other structures on Galveston that are also disrupting and hindering the natural movement of sand. Structures like the seawall, in addition to groins and geotubes. Now, do these structures also contribute to beach erosion? Well, in a nutshell, yes, they do. Here we see the other coastal structures on Galveston Island that disrupt the natural movement of sand, and they include the seawall, groins, which are built perpendicular or at right angles to the beach, and typically are constructed as a series, and also geotubes, which are buried along the vegetation line in order to prevent the beach from being eroded further back. In this case, the geotube has been exposed by beach erosion. As a result, most beaches on Galveston are eroding away and need to be periodically replenished with sand brought in from other locations. And that concludes this lecture.